Well, thanks for the invitation, for Rick inviting me out, and he asked me to talk about the long-range outlook and El Nino weather pattern. Sometimes in the weather outlooks there's not much to talk about, but this year there is. We've got a lot going on. Sometimes as meteorologists we deal with day-to-day weather, but we get asked to talk about more climate because people want to know what's going on in the next few months. And that's what I'm going to let you know about. Let me skip on over here. Of course, our main focus in the Lubbock office is severe weather. We sort of exist to protect life and property, but as we get into the fall, usually, I sometimes am almost as busy or even busier in the winter weather, dealing with our emergency managers, dealing with the local media, and getting the word out for impending winter storms and things that can protect life and property. Of course, let me skip past some of these slides. We have been in a very wet pattern up till about early to mid-June. That came on as we started entering the El Nino, but I was just looking at the 60-day precipitation percentage of normal. And I think I have some slides coming up on that. And we're pretty dry. Especially from about Lubbock and off the Caprock and the Rolling Plains down toward Stonewall and Kent County. Some areas have seen somewhere between 5 and 25% of normal just in the last 60 days. So after a really good spring, we have about 60 days of dry, and that has come with a lot of 90-degree temperatures, which is of course good for the cotton, but it does dry things out quite a bit. So some of you may remember just 2 months ago the flooding we had here on the Central South Plains. Just briefly talking about our forecasting methods, you know, there's several ways we forecast. Persistence is pretty good this time of year, at least in the summertime. You know, what was it yesterday, and the weather pattern hasn't changed, and we'll go with that again. And we're still in that kind of right now with temperatures in the low to mid-90s every day. When we talk about climate forecast, it's a little different than day-to-day weather. We're not as specific because we can't be, and we deal more with the averages. So we're looking at what normally happens in the fall or winter and how that compares to some of the climate signals that we see you know, over time. And then, of course, when we're talking about day-to-day weather, we use numerical weather forecasting, which is really our computer models that play out the weather over the next several days. But the challenge as meteorologists is, well, we get 3 or 4 different answers. So what do we go with the forecast? Well, first of all, how predictable is the weather? I've noticed in my career, I've been a meteorologist about 25 years, weather forecasting is improving, and even climate forecasting out several months or a year is improving. Sometimes maybe not as quick as we'd like to see, but this graphic, I don't know how well you can see that, but this shows our success, for example, at forecasting 1-inch rainfall events. Now, we don't see as many of those in our part of the country as maybe you do in other places, but the skill of the one-day forecast, at least in terms of 1-inch rainfall events, has doubled since 1965. The 2-day forecast has quadrupled over that time, and you could probably get somewhere close to these numbers on other variables like wind speed, you know, temperature. Those are measured a little differently. And our 7-day forecast in terms of the 1 inch is about as accurate as our 3-day forecast was a decade ago. And I remember when I showed up at Lubbock, some of the older forecasters, many of which have retired, and this is probably going back to the 80s and even into the early 90s, sometimes we would forecast a winter storm and not even see any clouds. Now, if you know a little bit about weather, that can happen easier than you think of, because we can get what we call a dry slot on the south side of the storm that comes in. But you know, we don't see that as much anymore as we did even 10 or 15 years ago. We've learned more, our computer models are better, and I think we just have a better grasp of what's going on. Probably a lot of that can be contributed to the computer models, which are able to model the atmosphere, the physics of the boundary layer, and a lot of other things like that. But How predictable is the weather? Well, the answer is not very. Most of you probably know that. We have something called TAWC, which is a condition in physical systems that sometimes make it nearly impossible to predict a system, how it will appear in the future. So as we go out in time, the forecasts will get off by a greater and greater amount. And even if we could measure everything perfectly, the temperature at the ground, the temperature aloft, the wind speeds, even then you're going to have a divergence of solutions. So can the flapping of the wings of a butterfly result in things that result in a hurricane? Well, yeah, theoretically that can happen, but measuring all those at infinite points becomes kind of problematic. So, but I'm here to more talk about longer range forecasting. I think everyone's concerned about what's going to happen this fall, winter, and maybe even into next spring. But when we talk about those forecasts, those are expressed as probabilities of the observed average temperatures of rain. So about the best we can do, we actually get calls in the weather office for somebody months in advance to say, I have a wedding in June, is it going to rain that day? And we look at each other in the weather office and, what do you say to that? I don't know. So we can't be as precise as maybe we want to be, but we can have a good idea in some years about the long-range forecast out a few months. But in general, some bullets here, some takeaways. Precipitation forecasts are generally less skillful than temperature forecasts as far as climate goes. For strong El Nino and La Nina, precipitation skill can be as high as temperature skill. And the forecast skill for temperature peaks in the late winter and the late summer. The lowest skill is in the late spring and late fall. One thing I'd like to say before we get into talk about El Nino and what we expect is usually a lot of these long-range forecasts aren't that good. A lot of things that affect weather out weeks or months can only be predicted out maybe a couple of weeks. Fundamental changes in the jet stream, what we call the Arctic oscillation. Will cold air, Arctic air dump down into here? Will we get fronts that produce precipitation? A lot of that we can only see maybe at best about 3 weeks out. So if somebody asks me what's going to happen in November, well, your guess is as good as mine. There are a few things though, and one of those is the ENSO phenomenon, La Nina and El Nino, which seems to have a very strong signal if it's strong enough and can help us forecast with some success out a few months. And that's what we think we have going on this year. But the humans add about 30% to the overall skill forecast of the models. I'm glad that number's not lower than it is because we were talking in our office yesterday that we may be the last generation of forecasters that actually forecast and the computers don't do it for us. And some of your forecasts that you may see on your phone now are completely automated. I still think the ones that have human input are better, especially in those first few days. And the Weather Service is, even though we're starting to rely on blended models to do our forecast, I think we're still better than just a pure automated forecast. And a lot of that comes from knowing the local effects, the local terrain. How much higher are the wind speeds usually in West Texas than the models are saying, for example. And if you've been out here a long time, you kind of start to pick up on those patterns. Well, to talk about the drought, to show you sort of the evolution of that, we are in about, depending on how you define it, about at least a 3 or 4 year drought. This was the U.S. Drought Monitor in July of 2011. And you can see that darker shade is the highest category of drought, the exceptional drought. And that covers all but about parts of central, north and northeast Texas at that time. Then we got into 2012, we had a little bit of a reprieve, but still not too good conditions out here in West Texas. We got into 13, we started to see drought intensify across most of the state and out here near Lubbock, northward up toward the Panhandle, and then especially over in the Rolling Plains and up toward Wichita Falls, the worst category drought continued. 2014, we saw some improvement, especially on the Caprock. Still pretty bad conditions worsened up in the Panhandle and then along the Red River, near and west of Wichita Falls. So here's the drought monitor just a few days ago. we pretty much eliminated the drought, at least according to the drought monitor. Here in most of West Texas, you can see a little bit of yellow there. That's abnormally dry. Even in the eastern South Plains, here in Floyd County, and then eastward, and you can see where some more significant drought impacts are back in central and east Texas, where they've had a pretty dry situation over the past 2 months, for example. Now, one thing about the drought monitor, and a lot of you may be aware of this, it's sort of twofold. We have the short-term drought, which is agricultural concerns, and that deals more with soil moisture profiles and how much rain you've had in the last few days and weeks and months compared to what you should be getting on average. And then we've got the hydrologic, which are lakes, rivers, and to some extent maybe the aquifer. And you know, we're almost in a perpetual drought here in West Texas in terms of water storage. You know, we've seen Meredith come up, White River Lake is still down, Lake Allen Henry came up due to some rains, but you know, it's going to be tough. If we weighted the hydrologic side, I think we'd always be in a drought here in West Texas. But it's amazing. It usually takes, when we get into a drought like this, it takes flooding conditions to replenish those reservoirs. And a lot of flooding. And we haven't even had enough to fill up all of our lakes here. Let's talk about El Nino. This is, the whole system here is called ENSO, the El Nino Southern Oscillation. And what it is, it's sort of a flip-flop of water temperatures along the equator. Here's South America. And it varies in periodicity. It runs for about 3 to 5 years. Sometimes we'll have a couple of maybe La Niñas or El Niños in a row that weaken and then come back. But the La Niña is the cooler waters there, and El Nino is warmer. Well, how much warmer? Well, that depends on the strength of the what's going on. Right now, we're in a El Nino, and water temperatures are, for this time of year, are about as warm as we've ever seen since we've been keeping records going back to about 1950 on these water temperatures in the Pacific. So I won't spend too much time on this graphic, but the normal state is you get upwelling off South America. That keeps the waters relatively cooler along the equator, and the pool of warm water and the rain stays back toward Indonesia and Australia. Now, we do get some rain further east than that, but the trade winds sort of keep that system going and keep the upwelling, and the water is in the average state, whatever that is. But when we get to La Nina, what happens is you get the trade winds weaken, and this warm water pool starts moving more out toward the central and eastern Pacific, and that creates this warm water, this pool of energy down to our south. And when that goes on, it affects not only the ocean circulation, but it affects the jet stream. And if conditions are right and the atmosphere couples with that, we can get a lot of that energy from that warm water affecting us. And really what happens is the subtropical jet stream, the jet stream that's down usually from here southward toward the equator, begins to come more active and pull some of that energy up in our direction. So this is kind of a graphic of El Nino conditions back in July, but a month and a half ago. And you can see really warm water all along the equator, and even warm out in the further north in the Pacific. And that usually makes for a very active Pacific hurricane season, but El Nino usually have a suppressed Atlantic season, which we've seen. We've had a few hurricanes, but nothing landfalling in the U.S., and most of them have been weakened. So all this talk about El Nino, what does this mean for us? Well, it depends on how strong it is. Right now it's on pace to be with some of the strongest. The way we do this, just real quickly, if it gets a ½ degree Celsius above the average, that's a weak. 1 degree is moderate, 1½ degree is strong, and if it gets 2 degrees Celsius, which would be about 3½ to 4 degrees Fahrenheit, of the average water temperature in a particular region down there that we monitor, we call that an extreme or very strong. Well, right now, and a lot can happen in 2 to 3 months, but we're on pace for an extreme El Nino. Right now, the temperatures, the weekly average in the 3.4 region, which I'll show you in a minute, is running about 3 to 4 degrees above normal. That's a strong, really technically that's in the extreme category. But just to show you what can happen, I'm not making a forecast right now. But if you press me, I will make a forecast on rain and snow. I'm hesitant to do that, but I'll give you my opinion anyway. But for strong to extreme El Ninos, now this is for Lubbock officially, for the winter months of December through February, that's climatological winter, our precip goes up from about 2 to 2.5 inches over that time. That may not sound like a lot, but our average is only about 2 or 3 in that whole time period. So we could double our rainfall. What's even more interesting to me as a meteorologist is our seasonal snow increases from 6 to about 13.5 inches. Now this is those top 2 categories of El Nino. Our annual snowfall in Lubbock is only about 8 or 9 inches. So that would be, just with the strong and extreme thrown together, somewhere maybe doubling our winter snowfall. Now again, this didn't include the snow maybe in November or late winter into spring. So 5 of the 6 that we've seen in the strong to extreme category have exhibited above normal precip and snow. Here's an example of an extreme El Nino. This is not what I'm forecasting this year, but we had another one in 97, 98. This was the winter of 82, 83 where we had an extreme El Nino. And if you look on the first line to 82, second 83, this is just the snowfall. In November we had 1/2 inch, nearly 7 inches in December, 25 inches in January, 3 inches in February, a trace in March, and then 5 inches in April. So the seasonal snowfall total that year was 41 inches, with 25 coming in January, and 5 inches even fell in April, which we normally think we're kind of getting out of the snow season. So that's an example of what can happen in an extreme El Nino year. The 97, 98 was more of an impact in parts of the country, like in California, where they had some high tides, a lot of erosion, mudslides, and big rains. We didn't see a bump, really that much of a bump up in precip or snow that winter. So there's more going on than just El Nino. Those shorter range changes that I talked about, the jet stream configuration, those occur on a shorter time scale. One thing we haven't seen in El Nino yet is the trade winds haven't weakened down there. And that water that I showed you that was back, even though we see some pretty warm out towards South America, that's kind of looking at the oceanic heat content, but one thing we'd like to see if we want to weather is a little bit warmer temperatures moving a little farther east towards South America. And that would increase our chances. So this year, in 1983, some examples that happened that year, the biggest single snowstorm occurred in January 20th and 21st, 16 inches in Lubbock. The largest 24-hour snowfall, if you count overlapping more than one day. And we had the most snow ever in January, 32 inches. The only record that wasn't broken was the single day, calendar day record, which was 12 inches back in 1961. So what can we expect? Well, we don't know for sure. A lot will depend on what El Nino does and how these temperatures respond. And do we get a favorable jet stream pattern to take advantage of the heat and energy down to our south? That's a lot of ifs, but certainly I think the probability of getting well above rain and snow in the wintertime were certainly much higher than an average year. So, what are we really expecting this year? I put question marks beside these. Will we see more big snows? 8 to 12 inches is a pretty big snow for Lubbock. Obviously, outside of agriculture, that could have a big impact on travel, and all the things that emergency managers that I work with in the wintertime deal with, opening up shelters, roads being closed, etc. And then all the other things that go with that. Now you might have seen the long-range outlook shows for cooler than normal temperatures. Does El Nino mean a bitterly cold winter? Well, that's usually not the case. One of the reasons I think the Climate Prediction Center is forecasting cooler than normal in those winter months is because typically, if you look back in El Nino years, you don't get necessarily a lot more cold weather outbreaks, but what you get is more cloud cover due to that Pacific jet stream, and that results in the daytime temperatures being a little cooler because you have clouds around. So it's not necessarily for or against, you know, a really cold winter. It's just that on average, you get some cooler days due to maybe some more cloud cover and some more storms hanging around. But, you know, it doesn't necessarily mean snow. It could be a wet El Nino year, but our temperatures aren't that cold, which means we could have rain or maybe mixed precipitation in terms of sleet or icing. This is not taking in Lubbock, but this one is. This is that 82-83 winter from the Avalanche Journal. So could we be dealing with this? I think we could. If I had to make a forecast, I'm reluctant to do so. But does anybody remember how many inches of snow we had just this past winter? Well, remember, that was coming into an El Nino year, and to the extent that that might have affected our wintertime precipitation. We had 14 inches just this past winter. That sounds like a pretty big year. Well, with El Nino being as strong as it is, I think we could potentially go well above that. And although 41 inches is probably a crazy forecast, certainly getting up in the 20s on snowfall is not out of the question. Of course, again, some of that depends on the temperatures. It's not going to snow if the temperature profile is pretty warm down in the low levels. We'll get some other type of precipitation. But I think from agriculture interest, you just want precipitation of some sort, right? Just to show you real quickly, here's the regions we monitor down there, and where these 3 and 4 overlap, that box in the middle, you might have heard of the Nino 3.4 region. I just pulled these up yesterday. The 3.4 weekly average is 2.3. That's really, really high. I mean, we're talking about definitely in the extreme El Nino range. And here's the 3.4 chart. Here's September. So here's what's been happening since February. Once we get about here, we're in an El Nino. You know, but the 0.5 has to be there for 3 months, and it's a rolling average, and the way it's figured. So by the time you really know what's happening in an El Nino, it's kind of like the economy. It's already passed. You've worked up the averages. But we definitely are in one now, and you can see it stair step up. We had a little dip down, and now it started back up just in the last week or two. So that's heading up pretty interesting. So it doesn't affect, and here's the climate forecast system model. We're right here. It kind of dips and then peaks, but this is a little lower. Here's 2. But this model hasn't been doing very well, but I thought I would show it. And some other models, here we are. The yellow line would be sort of a model average, and I think this is a little bit old, but you can see here's 2.5, and the yellow line of sort of an average of a bunch of models shows it up toward between 2 and 2.5. This was from the LA Times, and the source was the NOAA Climate Prediction Center. It's a little bit old, but I just wanted to show you, this is the average temperature in an El Nino, and here is this one. We're crossing above, well, the gray is the strongest El Nino on record. And back in early August, we were crossing that, and at that point, so we're somewhere in here again. So we're rivaling the strongest one at this point in the year. Quickly on some rainfall graphics, this is the precipitation percent of normal year to date. As of a couple of months ago, look how wet we were from January through about July. And this is 60 days. And these numbers are 10, 25% around Lubbock. A little bit better up in the Panhandle. They've benefited from these spotty rains and these thunderstorms that developed up there. And one thing I wasn't going to talk too much about today, but I talked to David Solis at DPS the other day. He said a lot of folks are starting to worry about a brief fire weather season. Now, we normally think of fire weather in the springtime, early spring, late winter. But we're dry right now. We're having some windy days. And until these El Nino rains start, if they do, we're going to have a little bit of an increased fire threat. We got fuels that are curing, and we got some decent fire weather conditions, probably not like spring, but that's something we may deal with in the next month, month and a half. Skip past that. So the outlook from the Climate Prediction Center is typical of an El Nino year. This is for the winter months of December through February. This one actually shows the mid-range value of the 3-month precipitation outlook, the distribution. So for example, how much will we be above normal? And you can see the darker shades of green are all along from Southern California, across Texas, and then the Gulf Coast and up the mid-Atlantic coast. And this is what you would expect. So the biggest input, I think, to their forecast is El Nino this year. The other things that go into that are long-range model predictions, current trends, and also soil moisture. That's something that actually feeds back into the atmosphere. Like we did in 2011 when we were so dry, we should have anticipated an extremely hot summer here in Texas. And we did to some extent, but I think we're learning more how critical, if your soil is extremely dry, you're going to get hot in the summer and you're going to get cold in the winter with radiation cooling. But as you see from the outlook, it doesn't affect everywhere of the country equally. As you go north of here, you get out of the wet pattern, again on average, and you got dry up here in the northern Rockies, in the Midwest, and even parts of the Ohio and Tennessee Valley. And that's what the typical El Nino pattern is. Warm across, so they may have mild, maybe it's a good winter to be in Fargo, North Dakota. Although to me it would still be cold even if it was well above normal. And then dry in a lot of the wet, a lot of the east, but not all the way down to the Gulf Coast. So the wet weather is along this Pacific jet stream. So a typical, and one thing to caution, you can't blame any one storm on El Nino because El Nino is a climate pattern. You could say we're having El Nino-like storms, but you got to be careful because the day-to-day weather is dependent on what's going on right now. To even define an El Nino, we have to look at long-term averages. So there's really no such thing as an El Nino storm, technically. And here's another look at the outlook for the winter. Below normal, slightly below normal, or better chances of below normal temperatures for the winter months. And the 3-month precipitation outlook above normal. That 40%, there's 3 categories, above, equal, and below. That may not seem like much, but to have that second shade of green painted over your area is pretty good. For as long as we saw the browns in the 3 to 4 years of drought. So that is good news. And if you look at some out maybe a little before then, October, November, December, January, you'd see pretty much the same pattern. The above may not be as big yet, but as we get more toward November, December, that's when El Nino, if it's going to kick in and result in above normal precipitation, it's probably going to do that start about November as we get right knocking on the door of climatological winter.